Hello my dear students. Today we are going to discuss about one of the important topic that is known as equations in one variable. Okay, it is one of the important topic from the grade 8 for all boards. So let us see. So first we will see the definition. An equation, a linear equation is nothing but an equation in the form of ax plus b where a and b are the real numbers and a must be non-zero is called a linear equation in one variable. The must condition is that the value of a must be non-zero. This a must be non-zero, right? And this b may any real number. Okay. So why it is called linear? What do you mean by linear? Linear means the higher power of the variable in an equation. So if here in this equation or in this form of equation the higher power of the variable is always equal to 1, it is neither less than 1 nor greater than 1, but it should be exactly equal to 1. So then we can call such a linear equation as a linear equation, and it is in one variable. So one variable means here we have x is a variable. So this equation has only one variable x, right? So that it is called a linear equation in one variable. Or we can also define it as a linear algebraic expression in one variable which is equated to 0 or any constant is nothing but a linear equation in one variable, right? The equation may be like this: 2x plus 3 equal to 7. So this may also be a linear equation in one variable because it has a variable, one variable having its higher power equal to 1. Clear? So this may also be a linear equation in one variable. After this, we must note that this equation has one variable with its higher power equal to 1. The higher power of variable x is always equal to 1. So the example for this we can see, in general the linear equation in one variable is expressed, or it is denoted by this way, that is ax plus b equal to 0. And the examples will be like this: 2x plus 5 equal to 0, or it may be x by 2 plus 5 equal to 0, or it may be y minus 3 equal to 0, it may be x plus 5 equal to 7, and so on. So if you observe all these equations, each equation has only one variable, that is either x, y or z, and it is equated with 0 or any constant. Here in the first three equations they are equated to 0, the algebraic expression is equated to 0, and in the fourth one it is equated with one more constant, 7. So this is also be a linear equation in one variable only. Clear? So after that we will discuss about the solution of such linear equation in one variable. In the previous standards, you might have studied about the solution of an equation. What do you mean by solution of an equation? We will define the solution of a linear equation as a solution of linear equation in one variable is the value of variable which satisfies the given equation. That is, if we substitute the value of x, if you substitute the given value of x in the given equation, the LHS, the values of LHS and RHS will be equal. Like some example is given, suppose, or we can more precisely we can say, to check whether the given values of x, say they are x equal to 1 and x equal to 2, to check whether these values of x are solutions for the given equation, say x plus 1 equal to 2, what we need to check here? We need to substitute the value of x as 1 in the first this given equation. In first we need to substitute in LHS and check whether it is same as RHS. So here the LHS is x plus 1 for this equation. Here the equation is this one, that is x plus 1 equal to 2. So we have substituted x equal to 1 here. So x plus 1 means 1 plus 1, that is equal to 2, which is same as the RHS. What is RHS? LHS is x plus 1, RHS is this x 2 only. So on substituting x equal to 1 in this LHS, we are getting equal to value equal to 2, and which is same as the RHS of the given equation. Hence we say that value of x equal to 1 satisfies the given equation. Hence we say that x equal to 1 is a solution of given linear equation in one variable. We can check for x equal to 2. If we substitute x equal to 2 in the LHS of the given equation, what we have? We have x plus 1. We substituting x equal to 2 here, it gives us 2 plus 1 which is equal to 3. But our RHS in the given equation is 2, means what it says indicates, it shows that the LHS and RHS are not equal, means the given equation is not satisfying the given equation. The given value of x is not satisfying the given equation, that is LHS and RHS are not equal. Hence we say that the value of x, that is x equal to 2, is not a solution of given equation. I hope everyone understood till this point. So what we have seen up to now, we have seen the definition of linear equation in one variable, and we have seen what do we mean by the solution of a linear equation in one variable. Now let us try to solve the equations. Now the equations may be in different forms, so let us see how to solve the linear equation. Okay, so we are going to solve the equations which have the linear expressions on one side, that is ax plus b is on left side and the number on the other side, that is constant term, is on the other side. Let us see the examples here. The question given is solve the following equation. The equation given is x minus 2 equal to 7, which is a no doubt a linear equation in one variable. It has a variable x, only one variable x, and it is in the form, or the higher power of x is 1. So we can say it is a linear equation in one variable. Now we need to solve this. So solving this linear equation is nothing but finding the value of x by using some algebraic operations. Let us see how it can be solved. So here we need to find the value of x satisfying the given equation. So what to do? We have to follow this step. So first, to get the value of x means we need to express the term of x to the left side and remaining all constant to the right side. So transforming or transferring the constant from one side to other side is called the transposition or transposing. The transposition, we can say, the method of converting or transferring one constant to one number or any term from one side to other side, or changing the side of a term in an equation, is nothing but the transposition. Okay, so here we need to transpose this 2 from left to right, or we can say it is transposing that 2 to the RHS of the equation. Means what we need to do, we need to add, since here 2 is subtracted here from x, we need to use the algebraic operation, opposite algebraic operation of this one. Here it is a subtraction, so we need to add on both sides this 2. So adding 2 on both sides, what it gives us, the left side x minus 2 will be kept as it is, we need to add 2 to it, and the same 2 is added to on both sides. Means here we need to balance the equation, the balance will not be disturbed here. So adding 2 on both sides or transposing 2 to the RHS of the given equation, it gives us x equal to 9. Taking this 2 to the right side, adding 2 on both sides, this minus 2 plus 2 from left side will get cancelled, and the right side will be 7 plus 2, which gives us x equal to 9, and which is nothing but the required solution for the given equation. Clear? So this will be the required answer. Now let's move ahead. The second one, let us solve the equation 7x minus 9 equal to 16. So see the step 1. So what do we need to do here? So first we convert or transfer the constant with the term of x to the other side, if it is there. So here we have minus sign 9, a constant, with this 7x, the term of x. We need to convert this to the RHS. We need to transfer this minus 9 to the right side. Since it is minus 9, we can say we need to add 9 on both sides, or we can say the transposing 9 to the RHS, or transferring this 9 to the RHS. So the both are one and the same. So adding 9 on both sides, what it gives us, we have 7x minus 9, add 9 to the left side and add 9 to the right side also. So addition of 9 to the left side will cancel that 9 with this minus 9. So this 9 will get cancelled from the left side. That is, 9 is vanished from left side and is taken to the right side. So 7x will left to the left side, and 16 plus 9 will become 25, which will be on the right side. Now 7x equal to 25. So after transposition also, we are not able to get the value of x or the solution of the given equation. So here what we need to do, again we need to simplify, or we can say we need to remove this 7 which is with x. Okay, so what to do here, what is the relation between this 7 and x here? So they are in multiplication of each other. So again we need to transfer this 7 to the right side with its opposite algebraic operation. So since it is in multiplication, we need to divide that 7 on both sides. That is the opposite algebraic operation of this multiplication. So opposite to multiplication is division. So we need to divide that number on both sides. So we can say divide both sides by 7, right? So dividing by 7 on both sides, we have the left side will become 7x upon 7. That 7 will get cancelled. That is, 7 will be vanished from left side, will be removed from the left side, and it is taken to the right side with its opposite algebraic operation. Multiplication will become division, means that 7 in multiple will go to the denominator of this right side. So it becomes 25 by 7. So which is nothing but the required solution for the given inequation. Clear? So this is one more type of example. Now let's see the sum number 3, next type of example. So here the equation given is 14y minus 8 equal to 13. Clear? So this is the given equation. We need to solve this. Here the variable is y. In the previous two examples, the variable was x only. Now the variable is y. So we can say 14y equal to 13 plus 8. So the equation given is 14y minus 8 equal to 13. So need to transfer this 8 on the right side. So it will give us 14y equal to, since 8 is in with minus sign, so if you want to take it to the right side, it will change its side and along with its sign. So minus 8 will become plus 8 to the right side. So 13 plus 8. And how much is 13 plus 8? It is 21. So 14y equal to 21. Again we have a constant with y. So that should also be removed. That should also be taken to the right side. So for that we need to divide. So since 14 is in multiple of y, we need to divide each term by the same number 14. So dividing by 14 to both sides will gives us 14y upon 14, that 14 gets cancelled, and the right side is 21 upon 14. So simplifying that 21 and 14 with 7 will gives us 7 3s are and 7 2s are, means the value we will have for the y is 3 by 2. So we can say 3 by 2 or y equal to 3 by 2 is the solution of the equation 14y minus 8 equal to 13, right? So this is the solution for the given equation. Now we will see for a few more example. The next one somewhat complicated or somewhat some different form of the sum. So here we have the coefficient of x are in fractional form, right? The coefficient of x is not a integer, but it is a rational number or a fractional form. So we can say x by 3, the given example is x by 3 plus 1 equal to 7 by 15. So here our first step should be, we need to transfer, or we need to remove a number added or subtracted with the term of x. So here 1 is added with the term of x to the left side, we need to take it to the right side. So since it is an addition, when it goes to the right side, the sign will change. So 1 will become minus 1 here. And 7 by 15 minus 1, this one is a rational number, this one is a 1 only. So we need to simplify, we need to take LCM as a 15 and take just cross multiplication. So here 1 means it is only 1 by 1, so take cross multiplication, 7 into 1 and 15 into 1. So 7 into 1 minus 15 into 1 divided by 15, or simplifying it, it will give us 7 minus 15, or minus 8 by 15 is x by 3. Again, x is not free from the constant, it is there, 3 is there with x, so 3 is in division in the denominator of x, or it is divided by 3, x is divided by 3. Okay, so to remove that number in denominator, we need to again use the opposite algebraic operation. So since 3 is divided to x, we need to take it to the right side with the multiplication. Okay, so that 3 will go to the right side with its opposite algebraic operation, that is this division will become multiplication, or it will go to the right side in multiplication with its reciprocal. Actually it is a number in the form of 1 by 3, so when it goes to the right side, it will become 3 by 1 in multiplication. Okay, so it will be x equal to minus 8 by 15 into 3 by 1. So this 3 by 1 minus 8 by 15, so these two can be simplified, 3 5s are 15. Okay, so it will become minus 8 upon 5. So that minus 8 by 5 is nothing but the required solution for the given equation, right? Hope everyone understood this example. Now students, after solving these examples, we have some application of this linear equation in one variable, or the application to solve such equations in which the constant variable is on left side and the constant is there on the right side. So let us solve some more few examples in this application. Some applications is nothing but the word example. You will be given some word example, we need to first convert or express it in a linear equation in one variable form, and then solve it by as usual method. Let us see the first example. The first example given here is, if the question will be like this, you can read the sum very carefully to solve such example. If you subtract 1 by 2 from a number and multiply the result by 1 by 2, you get 1 by 8. So what will be the number? So read the sum carefully. If we subtract 1 by 2 from a number which we don't know, we need to find, and multiply the result, means multiply that subtraction of 1 by 2 from the required number, and multiply the result, whatever we get, that difference, it is multiplied by 1 by 2. That gives us 1 by 8. That number will, simplification will gives us the number as 1 by 8. So that number we need to find here. So in such example, first we consider the required number as x and try to operate these operations with this x. So what it is given here, if you subtract 1 by 2 from a number, so subtract 1 by 2 from number means subtract 1 by 2 from x, means it becomes x minus 1 by 2. And what is given, multiply the result, means multiply that x minus 1 by 2 by 1 by 2 again, means that expression will become 1 by 2 times x minus 1 by 2. So what it gives us? It gives us 1 by 8, means it is equal to 1 by 8. So in this way, using this condition, we can have the equation of this kind. 1 by 2, first 1 by 2 is subtracted from the required number x, and that result, if we divide it by 1 by 2, it gives us 1 by 8. So this is so simple. So once you got such type of equation, it is again obviously a linear equation in one variable. The higher power of x is 1 and this equation has only one variable x, so it is linear equation in one variable. So as we have solved the previous example, the same way we can solve this equation now. So first we need to remove this 1 by 2 which is multiplied this binomial. So taken 1 by 2 to the right side, it will become its reciprocal, 1 by 2 will become 2 by 1. So it is 2 4s are 8, so the right side becomes 1 by 4. Okay, and then again we have 1 by 2 with x, so we need to take this 1 by 2 to the right side, which is with negative sign. So when we transpose this minus 1 by 2 to the right side, it will become plus 1 by 2. The transposition will change the sign of that term. So minus 1 by 2 will become plus 1 by 2. Now it is the sum of such rational numbers 1 by 4 and 1 by 2, and most of you know how to add such rational numbers. If you don't know, I will just explain how it can be done. So in such case, first we need to observe the denominators. If the denominators are in the multiples of each other, so here the greater one will be the multiple of the smaller one in general. Okay, so 4 is multiple of 2. So by which number I need to multiply this 2 to get 4? I need to multiply it by 4. So for balancing purpose, we need to multiply and divide by that number, not only to multiply denominator only, but we need to multiply as well as denominator to this whole rational number 1 by 2, so that our denominator will become 2 into 2 4 and numerator will become 2 into 1 2, that is 2 by 4, so that the denominator become equal, and it will makes easy to add such rational numbers with equal denominator. If denominators are equal, we need to simply add the numerators. So 1 plus 2 divided by 4, so it gives us 3 by 4. So we can say the value of x is equal to 3 by 4. Understood, students? The answer will be equal to, the solution of the given equation will be 3 by 4, or we can say, as it is a word example, the answer should be given properly. So the value of x we got. So what is x we have considered? We have considered x as the required number. Hence we can say 3 by 4 is the required number satisfying the conditions given in the example. This is one of the word example here, which is the application of this linear equation in one variable. The solutions of linear equation in one variable. We will try one more example. See here. The perimeter of a rectangular swimming pool is 154 meters. Its length is 2 meters more than twice its breadth. What are the length and the breadth of the swimming pool? So here again, you can just read the sum carefully. Perimeter of a rectangular swimming pool. So a geometric figure we have here is rectangle. Okay, so perimeter of a rectangular swimming pool means perimeter of a rectangle is given as 154 meters. We know what is the perimeter of a rectangle that we use here. Along with this, you are also given one more additional condition. Its length is 2 meters more. Read this here. 2 meters more. It is more. More means larger. Means we need to add 2 meters. So to which it is 2 meters more than what? It is 2 meters more than twice of what? Twice its breadth. Twice its breadth. So this condition is very, very important here to get an expression, to get an linear equation in one variable. So first we use the condition number 1. So to get the length and breadth, here if you see this condition that the length is 2 meters more than the twice of the breadth. So length is compared in terms of the breadth, or length is expressed in terms of breadth. So whenever the comparison is done between two terms, we need to consider the term with which the comparison is done. So here the comparison is done with the breadth. So we consider the breadth as x. Okay, so breadth is x, and then we can express that length in terms of x. So here you can see the length we have considered as x, and we can find the uh, breadth in this. Okay, let us see. So here 2 times breadth, length is 2 times breadth plus 2 meters. Okay, so before that what we need to do, we will discuss here. So here I consider length x and y be the length and the breadth of rectangular swimming pool. So since rectangle is a two-dimensional figure, it has length and breadth. So I consider let x and y be the length and breadth. So according to the condition given in the example, the perimeter of that rectangular pool is 154 meters. Just forget about the object given. Here it is given the swimming pool, but it is related with which geometrical figure? It is related with the rectangle. So just think about the rectangular perimeter of a rectangle. What we have the formula for perimeter? It is twice length plus breadth. Here we have considered the length and breadth as x and y. So I can write the formula for the perimeter as 2 times x plus y, and it is given as 154 meters. So here taking this, transforming this 2 to the right side means it is multiplication. I need to divide by 2 on both sides to remove this 2 from this left side. So dividing by 2, it gives us x plus y equal to 154 upon 2, which is equal to 77, or we can say x plus y equal to 77. So since we need the equation in one variable, we can't use two variables in the linear equation, because it is a linear equation in one variable. But we are considering two variables x and y, as we have two dimensions. So after simplifying, we can express any one of the variable. Either we can express x in terms of y or y in terms of x. As since we have considered length as a x, we can consider this breadth y in terms of length by this first condition, that the perimeter is 154. So we get the expression for y in terms of x as 77 minus x. So the first condition is given for the same thing, that the second variable can also be converted in terms of the first variable only. So whenever such two conditions are given in the example, the first condition can be used to convert the second variable in terms of the first variable. So after getting this, so here I can say x is the length and breadth is a 77 minus x. Okay, so these are the L and B. So now once we got the length and breadth in the same variable, now use the second and important condition of the given sum. What is the second condition given? It is given that the length is 2 meters more than the twice its breadth. So that condition can be used here. So if I consider L as a length, B as a breadth, I can write the given condition in this way. L is equal to 2b plus x, 2b plus 2 meters. Length is 2 meters more than the twice of the breadth. So twice of the breadth is 2b and it is 2 meters more, so 2 meters is added to it. So now express this L and B in terms of x. Length is x and breadth is 77 minus x plus 2 meters. And now simplify and get the value of x from it. So here we have the variable x on both sides. We need to take them to the left side only. So taken this minus 2x to this side will become plus 2x. So x plus 2x will give us 3x to the left side, and only the constants are left to the right side. So 154 plus 2 will become 156. And then again to get the solution of this equation, we need to remove this 3 from the left side. We need to take it to the right side. So since this 3 is in multiple, I need to take it to the right side with division. So I need to divide both sides by 3 here, so that 3 will get cancelled from LHS and it is divided to the RHS. So 156 is divided by 3, which gives us 52. So what is 52 is the value of x. But what is x here we have considered? Here we have considered x for the length of a swimming pool. So length of swimming pool is 52 meters. And what about the second dimension? It is the breadth. And the breadth of swimming pool we have considered as 77 minus x. So 77 minus 52. And how much is 77 minus 52? It is 25 meters. So in this way we can have the required dimensions for the given rectangular swimming pool as 52 meter. Length is 52 meter and breadth is 25 meters. So student, in this way we can solve such type of examples, the word examples, using the linear equation in one variable. Hope everyone understood these examples, and you can try more examples from your textbooks and practice them. So with this sum only today we stop here. We'll continue in the next video with more examples